Good morning, ma'am. Should we start now or we will wait till some more students will join to us?
Good morning. Yeah, around 56 have joined. Uh, Let us wait for 3-4 minutes more
Okay.
because the participants are more than 100. 3-4
Yes.
minutes more, then we can start. Let us start, Vipasha. Around 71 has joined.
Okay. So, good morning, everyone. On behalf of our department, Information Technology, I welcome you all on the fifth day of 3-week departmental induction program for the year of 2020 undergraduate batch of IT sponsored by Dept 3. Today we have our eminent speaker, Mr. Parthasarathi Mukherjee, on the topic Data Science, Past and Future, and a yoga session after the deliberation. Students, have any question, you can write into the Q&A section or you can raise your hand. So now I would like to request our faculty member, Mr. Jayabroto Chakraborty, to kindly introduce our today's speaker.
Good morning, everyone. Good morning, students. Your induction program is going on. So this is the fifth day. Today we have Mr. Parthasarathi Mukherjee as our guest. He will going to enlighten us with his thoughts. Now, Mr. Parthasarathi Mukherjee has a vast experience in the field of academics and industry as well as. So before he starts, I would like to introduce Mr. Parthasarathi Mukherjee. Mr. Mukherjee has started his career as an assistant professor in Brainware Engineering College. After that, he has joined ISI Kolkata as a project link person, where he has completed several projects, and all of his work has been published in different renowned international conference also. Currently, he is working as a data scientist in Takras Data. It is a New Delhi-based company. Also, he is pursuing his PhD from Calcutta University. With this brief introduction, I would like to invite Mr. Mukherjee so he can start his presentation. Thank you, Mr. Mukherjee, for being with us.
Thank you, Jabrato. It's so good to hear from an old friend with whom I have walked a long path, a same path, I would say. It's good to be back in WBT because my engineering degree was completed from under the same university, and that was a wonderful experience. Now it's always good to be back in old places. Anyway, I would start my presentation. So I would request all of the students. Okay, can you hear me clearly?
Yes, sir. It is
Okay,
audible, sir.
very good. So I would request all the students here one very simple thing that though I am presenting through a PowerPoint and presenting it like a very formal presentation, but consider this as a morning chat session, right? So you can ask me any question any time while I'm presenting. You can pause me, you can interrupt me in any way you think suitable. Please feel free to communicate with me. Let's make this not a session where I am only speaking. Let's make it a session where we are all speaking with each other and trying to clear some doubts, trying to clear some questions, or let's have a discussion also. Okay, so let's make it very informal. And but just to start the discussion, I would say that my intention today is to present something on data science. Now, you know that already, I think you have heard of this term data science many times because it's such a trendy topic in 2020 in the job market. And thankfully, in the time of COVID-19, where the whole economy in throughout the country and nationally and internationally, the whole economy was plummeting. The job market was like sick like never before. Even in 2009, the situation was not this worse. But in still in this period of COVID, data science recruitment was one. Okay, so I am actually the person in front of you who have been recruited during COVID-19. So that is a big thing, I would say, because it is only possible that it is only possible to be recruited in such a stream only if that stream is requires so many people. You know, that is why people are getting chance even in the most worst situation in the history of civilization. Now, uh, why this is happening? Okay, so I would like to take some time to discuss that why data science nowadays are so important. That even in the most difficult times, we can get recruited there and work with an honorable amount. Okay, so I will try to cover these things, and if you have any questions related to this, you can ask me anytime, right? So as madam said that my topic is the past, present, and future of data science. Just to make this presentation a little more attractive, I changed the title. So today we will be discussing that what was before data science, what is data science now, and what data science will be. Then I will discuss why data science is so important, why so many people are trying to complete a course in data science and get a lift in their career. Then the third thing that I will discuss is that what you need to be or how you will become a data scientist, what you need to cover. Okay. So first of all, let's go to the definition of the data science. Again, this is a very informal definition, but it's a good definition. You can see that they are saying that uh, your the data science is basically the study where we try to understand the data. We try to uh, get some different meaning from the data, and of course to visualize the data. Now, these three things are very important, right? So the first thing about the data science is that we must understand the data. I will discuss very soon that what we mean by understanding data, right? And then we need to by understanding the data, if we can understand the data properly, then we can extract more information from the data, which will be very useful. And finally, we want to visualize the data also. Now, visualization means showing some plots with the data. Like you see, whenever we watch a cricket match, the run rate, the net run rate, chasing run rate, all these things are shown in a plot. Someone is hitting fours, hitting sixes, and we can see a wagon wheel kind of thing where we can see the trajectory of the ball, that where the shot was taken, what was the length of the shot, and so many things. So this is visualization of the data, right? In fact, cricket is a very good example, a good domain where a lot of data science can be applied, and I will come into it so that it will sound more interesting, right? So three important things. One is to understand the data. The second is to get some extra information from the data. And the third is to visualization of the data. So these three things are very important that you need to be aware of. Now, what are the tasks that a data scientist must perform, right? So here are the technical lists. Okay, so the technical list that some data scientists in their everyday organization work does. But I will try to list out some informal way of the description of the task. So the first one will be like when you are a data scientist, what we need to do as a data scientist is to get hold of the data, right? So on what data you will perform your analysis, on what data you will apply your scientific activities. First of all, you need to get hold of that. So the one thing that you need is that resource can come from a database. Now the database can be a regular SQL based database, and uh, or it can also be uh, Mongo database, which is a different kind of structure. We say this is a collection. The data set can come from Excel files also. So the data can be anything. It can be text file. It can be a directory of thousands and thousands of images. It can be a SQL database. It can be anything. So wherever a person can store the data, it can be a directory, it can be a file, it can be a database management system, whatever it is, but that can act as a source of data for a data scientist. Okay, so first of all, you need to learn the technology associated with it. That means if you're a data scientist, the first thing that you need to know is how to get the data from the data source. So either you learn SQL, so you have to learn SQL or the structured query language that will help you to get data from database like Oracle or something. Uh, you also need to write some program that will get data from Excel files. So you see the range. In one part, you have simple functions that can get data from Excel file, and in another part, you need to learn languages like SQL, where which will be used to get data from the database. Now, that is a very important thing for us. Like you must have quite a range of programming expertise to get the data on your workspace. So in this way, you have to get hold of the data on which you will work. The next thing that you need to do is that you need to understand the data, right? So you can see that here in the second point, I have said that determining the correct data set and variables. So your data can have lots and lots of unimportant things, okay, which we do not want. Let's say, take an example. Suppose your task is to find take an image of a face, and by looking at the face, you need to apply some algorithm, some artificial intelligence technique that will tell you from the image of the face whether the person whose face it is happy or sad. It's a simple task. Say we are looking at the face, and the image, the computer program will tell us whether the person is happy, sad, or neutral. Okay, this can happen. Now, the picture can have a lot of other things, but we need to focus on the face only. So By this I mean that you need to localize your point, your region of interest inside the data. So you are not interested in what dress the person is wearing, what is the background, what other people's are there. You don't need to worry about that. You only need to worry about what is the expression in his face. So that is that is the process of determining what is the region of interest for you in that particular data, and you can work with it and reject the rest of the one. So this is very important thing in the life of data scientist, to pick the right one, the right content for this analysis, and reject the unnecessary things, right? Cleaning and validating the data is definitely one important task, and 60% of your time you have to spend on cleaning and validating the data. So it's like getting down in the dirty areas and make your hands dirty to clean the data. If your data is not clean, then you will not be able to analyze the things properly, right? Then what we do, then we try to use some plots, some like a histogram. We try to find out the histogram of the data, or some kind of pie chart from the data, or bar diagram from the data. These are different data visualization. So depending on your data, you want to plot different things, you want to visualize different things. Let's take an example here. Yeah, suppose I want to analyze the performance of Indian cricket team in one day matches. So what we can do is that we can collect data of their performance of one day matches in the past, say the past 50 matches I'm talking about, right? So what I will do is that I will collect that data, and we will have 50 samples of data for 50 different matches. What we can do is that we can just plot that how much India have scored in each of these matches. And to compare these plots, we may take a bar diagram, or we can simply put a line plot like this. So we just plot the values of the runs that is scored, and we can draw a line over it, or we can just plot the bar diagram. Now, if the data is something different, then you can think of a better visualization tool also. So suppose you want to know that in how many matches India have won by chasing the score. Okay, and definitely we want to forget the World Cup semi-final, uh, which was a very painful thing for all of us. So if we want to plot that performance of India, then maybe we will not use the bar diagram. Maybe a pie chart will be useful for us in that context. So my point here is that uh, you as a data scientist, you have the responsibility to decide that what visualization is necessary for the data that you are dealing with. So there is no hard and fast rule that if that you have to plot these things, or you have to visualize the data in this way, or you have to analyze these particular things. Yes, there are some baselines, some basic instructions, but in general, you are in the wild. So it's like a jungle, right? And you have to decide what you will do next. It's like the survival strategies in the shows that we see in the Bear Grylls show or something like that, surviving in the wild kind of shows. So working as a data scientist is just like that. So you are in the wild, you have many challenges, like winter is coming, like you don't have any water, something like that. And what you need to do is that you have to find what you have in your hand and make something out of it, right? So that sounds very difficult, but that is interesting also. Okay, people love that. And as the task is very challenging, people pays more for it. Okay, so whenever we discuss all this stuff, that data science is this, data science is that, we always think behind is that what we are gaining from it, right? So definitely we are gaining a lot from data science nowadays in terms of finance. Okay, so anyway, the next thing is that once we do the plotting, we do the initial analysis, we can understand something about the data. That what actually are the elements in our data and how they are related. Okay, so once we understand this thing, we can apply some different models and algorithm to get new information from the data, right? So here comes the interesting thing, that how data science has changed. Before data science, what we used to do with the data, right? So what we used to do in the data, we would say, let's again take the example of cricket. Suppose whatever the data getting generated in a one-day cricket match, uh, what we used to do is that we just put those numbers in a table and say, let's put them in a database. Let's put this in a database table, or let's create some Excel files with it. Okay, so ultimately for each match we will have a one Excel file, or if we can put the database, it will have a continuous set of tables, and then we can work something. Now, what do you see? What we used to see with the data in previous times, what we used to see is that what is the career average score of Rohit Sharma? This is one simple query that we can ask to our database person, and he can just find out what are the runs scored by Kohli runs scored by Mr. Sharma throughout his career. Sum it up, divide it by number of matches, and give you the result. So this is very simple thing. So we can also ask questions like, in how many matches, say, Ravindra Jadeja have scored more than 50 when India is chasing. So it is a little more complicated query, but again, it is not very difficult. So only you have to filter out that in which matches India were chasing. Then you have to filter out among these in which matches Ravindra Jadeja played or batted for India. Then you will just sum up again. Again, you will find out the scores and filter out those scores that is above 50. So this is another example, a little complicated query, but we can answer this with what we have in our data, what we have in our database or Excel files, whatever it is. So it is possible. So if someone knows Excel, how to get data from Excel, he can give you these answers if the questions are like this. This was old days, right? But now what we are doing here is that we are trying to enter the era of predictive analysis. Now, what is this predictive analysis? Instead of asking the question that whether Ravindra Jadeja, how many times Ravindra Jadeja scored over 50 or so, we are trying to ask this question that will Ravindra Jadeja save the day? That means India is chasing, maybe in a difficult task. Then at some point of time, Ravindra Jadeja came to bat, and we are thinking, well, will he save the day? Can Ravindra Jadeja take India to home? Can we win by innings that Ravindra Jadeja is going to make? So now we are not only asking about data that we already have, but we are asking questions that has not happened. So this is the most important revolution that happened over the years, over the recent years. So now we are not happy, not only happy um, about the information that we already have in the data, but we are also interested about the information that we may have in the future. So this is the future, right? So data science is not only helping us to understand what we have in the past, but also it is trying to give us a prediction of what is going to happen in the future. So here with this line, I want to separate our old era of data with database and other data warehousing schemes and the era of data science. I am not saying, remember very clearly that I am not saying that we are rejecting those things. No, not at all. But now they are even more important because they are working as the repository for the data scientist who will take data from there, apply some models and algorithms, and try to infer something from the data. Now, this is a very important term, infer. We will be using the term now and then. And once we can infer something, that means we are actually identifying patterns and trends in the data. Now, I will come to this with a more lucid examples, right? So if we can do some initial analysis and identify patterns and trends, then with the help of that, we can help business. And that is where the milestones are coming. So if we can help business with data science, then business will be interested to invest further in the data science. And if business feel, the business person, the giants of the business feel that yes, data science is doing good for us, then they will invest there, which will eventually lead to more investment in data science, that is more opportunities in data science, more employment option in the data science, and consequently more researchers in the data science. So again, if a research need to be successful in industry, then it must show that the business can have something good with it. Otherwise, there will be no employment and no investment with the data science at all. So from the traditional research perspective, this seems very bad. This is a business-minded talk, but that is unfortunately is the present scenario. Okay, in fact, it's actually the scenario from the very beginning of our civilization. If people can make money with this thing, then people will be interested about this thing, and more people will research on it. Okay. Now, what kind of tasks that we? Okay, do you have any questions so far? I have been speaking, like not giving you any chance to answer two questions. Do you have any questions? Okay. Uh, so, is there any chat? Okay, no, fine. So, what we are talking about here is what are the tasks? So, in data science, usually,
Partho,
yes.
actually, we have a question and session at the end of this lecture. Actually,
Very good, very good. Okay, so fine. So we can definitely take questions there. Anyway, so what are the tasks that we mainly do? One task is the three tasks. These are among the most three popular tasks in data science world. One is the regression, and the third one is classification, and the last one is called clustering. Now regression. So every task, like regression, classification, and clustering, in every task, what we uh, actually do is predict something. Okay, what we do actually is we predict something. So in regression, we predict a real number. In classification, we predict a probability, and in clustering, we predict a cluster. I will give three simple examples to illustrate this. Let's again take the example of cricket. Uh, Suppose we are watching a T20 match. Um, Okay, one thing that I'm not asking is that I hope everyone is familiar with cricket, right? I sincerely hope that everyone here is familiar with the cricket and the numbers associated with cricket. Okay, so anyway, so regression, let's take an example. Suppose we are watching a 2020 match, and after 10 over, one team, say New Zealand versus West Indies, is playing, and New Zealand has scored after 10 over, say 64, and with a loss of 3 wickets. Okay, so after 10 overs, the score is 64 for 3. Now, a very common question that we can ask here is that what will be the score after this 20 overs? What will be the score of New Zealand after 20 overs? So you will say, sir, this is very simple. Na? It is 6.4 now, run rate. So after 20 over, we will just multiply 6.4 with 20 and we will get something. So the score will be 128. Well, well, tell me, what is wrong with this prediction? Okay, you know that this will not be right. Like it's a very rare that New Zealand will score exactly 128 after 20 overs. See, they may score, but they may not also, because what will happen at the end of the after 15 overs, they will start accelerating run rate. They will try to hit more sixes, more boundaries, and things will change. We will see that maybe New Zealand have scored 192. This happens in cricket. So you will say that, oh, well, what happened? What happened? Why? What was wrong with my analysis? The wrong is that what was wrong is that we were not considering the dynamic structure of the data, right? So New Zealand maybe after the 3 wickets have fallen, New Zealand may lose more wickets, so they won't able to score even 128. Or it may happen that New Zealand won't lose any more wickets and they will score a lot. So my point here is that in these cases, we are trying to predict a number, that what will be the value of a particular parameter, like run here, what is the total run scored, and then we will predict to try to predict with something by considering the dynamic factors in the game, like what will happen, that what if New Zealand loses more wicket, what if the person who is bowling for West Indies get an injury and won't be able to deliver anymore. So these are the problems that we talk about. So our data science tasks have some kind of dynamic property in it which needs to be considered for prediction. That is why we need to use data science, right? The second thing is classification. So probability. So here again, let's take the example that what is the probability that New Zealand will score more than 150 in that match. So again, we are talking about the same metric like total run scored, but we are looking from a different perspective. That right now we are not talking about, we are not interested about the exact score. We are rather interested about mm, what is the probability that New Zealand will score something more than this or something less than this. You can have different ways of thinking that what is the probability that New Zealand will win the match? What is the probability that West Indies will win the match? What is the probability that New Zealand will win the match and will score more than 100? So we can have many such scenarios, and all these are very important queries related to data science and the stuff. So that is called classification. And the third task is for clustering, and nowadays clustering is gaining more and more importance. I will not be able to discuss these things, why the clustering is getting more and more important. Maybe in some more technical talk, someone can explain you later that why clustering is so important nowadays. But clustering is like we want to, we have some groups and we want to put one particular element in one group. Now suppose before the World Cup starts, say the football World Cup starts, FIFA thought that okay, we will not randomly make groups. What we will do is that we will put similar teams in similar groups. Then immediately I think already it came to your mind that, sir, what is similar? What do you mean by similar things? Similar teams. How we will say similar teams? Is Brazil and Germany a similar team? Is Brazil and Gibraltar are similar teams? How we will define these words similar? Again, in order to understand the word similar or similarity between two things, we need to take into account some parameters, some properties. Hmm? Like that what is the overall performance of this team over the last 5 years, and we can use that parameter, that those values to find out similar teams, and we will create group A, group B, group C, group D, group E, group F, and if similar teams will be put inside one group. Okay, so again, this is a very difficult task but very useful and fair task also. Okay, so we do that a lot of time. Whenever we sort things in our home, we put similar things in same places. Like say you have a lot of books in your home, so you will create an bookshelf and will put all your books there. And you have some gaming accessories. You will put those gaming accessories in a different cupboard or somewhere. So you will not mix up these different things in one place. So that is the idea behind clustering. We try to categorize things into different groups, and we try to put same things in the same group. Okay, the similar things in the similar group. Again, the term similar, I will put the term similar in under quotes. And the way we measure the similarity is a very important factor that we should consider. Uh, so these are some technologies which you may heard of, may not, but these are the trends that data science methods are used most regularly in recent years. So logistic regression, which is a very simple basic tool that we have in our hand, that is widely used. Okay, so 50% or most people uses logistic regression for their data science task. Neural network is again one very important term, very useful term, and but which is the second most used method. Okay, so just put these terms in your mind. These are very popular methods for data science. And when if you sometimes take a course on data science, maybe in your institute, maybe somewhere else, you have to understand and you have to implement all these methods by yourself. So why I have given this, that maybe logistic regression is most popular nowadays. It doesn't necessarily mean that if you only know logistic regression, then your data science career will be ready. No, what you need to do is that you have to understand all of these things, and based on the requirement of the uh, mm, particular project you are working, you have to decide which one of these methods you are going to use. Okay. Now, uh, what I was saying a little earlier was that how we will measure the similarity between the data. Okay, so I have said that in order to measure some similarity, you need to have some values or parameters associated to a data, right? Now, suppose so that is called feature. Okay, a feature of a data. Now, let me explain what feature is and what we are going to do with the feature. It will take just 1-2 minutes to discuss these things. Okay, so I hope you are understanding what I'm saying. So if you are not understanding something, you can pause me there. That's okay. Yes, there is a question and answer session, but you can also pause me in between. Okay. So suppose we are analyzing two marks of two students. One is student one, the second is student two, uh, and we are considering two students. One is student one, another one is student two, and we're considering their score in mathematics. So the first score of the student one is 65. The score of the student two is 85. Okay. Now, uh, what I'm saying here is that you can see that we can clearly distinguish these two students, that they are not same, right? Because we can put a boundary line between them, and we can say that yes, these student is separated from these students. Even we can say that they are different by that much marks, that 65 and 85. So student 2 has scored 85, so he is a good student, and student 1 is has scored 65, so he is not a good student. So we are putting them in two different categories. One is good, and one is not so good. And you can see that for these two data samples, we can do that very easy. But what if these students score the same marks in mathematics? Okay, so this is the question here. Say both of the student 1 and student 2 have scored 75. Okay, so what I'm worried about here is that if now I want to put them into different groups, because I know that there is something different in them, we cannot. Because from this perspective of score in mathematics, these student 1 and student 2 are not different at all. Okay, so we are stuck. That yes, we have these values associated with the students, which is working perfectly, but in this particular case of data, it is not possible. So we are very worried that how we will differentiate these students, how we will put them into different groups, how we will draw a boundary between these two students. We cannot do if we have only the score in mathematics. So what we will do is that we will consider another score, right? So say now we are considering the score in English and score in mathematics. Okay. So now a student 2 score is here. So you can see that he has scored something like say 17 mathematics and here they say 45 in English. So less than 50 in English. And student 1, he has scored the same score in mathematics, but he has scored more than 80 in English. So now you see, if we have these two parameters associated with each of these students, we can draw a boundary between them. Okay, and that is the trick. So if I want to distinguish one data from the other, then we need to draw a boundary from them. And sometimes taking only one parameter which is associated with the data is not sufficient to draw the boundary. It's not sufficient to distinguish between them, just like in this case. Okay, we are not able to draw a boundary between them. We're not able to put these students into different categories. We are not able to put them into different different groups. But here, once we are considering another parameter, we are saying that so this is a very interesting, this is a very simple example, a very childish example, I would say. But this clearly shows that if we increase the number of parameters associated with particular data, we say these are variables. If we increase the number of variables, then it is useful for us to create a line of separation between the data points. Okay, maybe I'm using too much technical jargon. To put it simply, we need to separate these data in one space, right? So here we have separated these data by, here I was using only one parameter, which is score in mathematics. Here I am using two parameters, and you can see that the separation is done. Okay. So this is the trick, and we say that now these parameters, we say that this is not a data anymore, we have features from the data. And this is a very important task to identify a feature of a data. Okay, and this part, this identification of important feature from a data, this phase in a data scientist's life is called feature engineering. Okay, this part of data science life is called feature engineering. Okay, so this is a feature, and it is a very important thing. Okay, now a simple example. Don't go too deep here. So once we have the feature, we can put, we can draw different decision boundaries, just like this purple lines. Okay, and the name here, this decision tree SVM, you don't need to worry about these names. These are only the name of a particular model that we are using for prediction. And you can see that in different models, we are able to put boundary lines between the data. Okay, these boundary lines look different. See, the SVM and neural network, they look some similar, but decision tree and neural network lines are quite different. But all of them have done the same thing. They have grouped the data into two groups. One is the blue group, another one is the red group, and it is done very successfully. Okay, so you see, this is the importance of doing a feature extraction, and this is the process of doing some prediction on the data, that you put them in different groups, and for them you need to separate them, and for separation you need to find out the proper feature for the data. Now these features can be used to identify similarity. That's one I was talking about. So when we're talking about similar football teams, you are thinking about parameters associated with football teams that will help you to group them in different categories. Or students, suppose uh, you want to put the students into different groups to perform some projects. So you want to put similar students into similar groups. That will help the teamwork. So that is why you need to associate some parameters to the students. We sometimes do that subconsciously in our mind, but the same method is followed mathematically in data science life. Okay. So now that we are here, we have data. We can extract some feature from it. Though I have not explained in detail that how we can extract features from it, because this is a very technical discussion. People do their PhD in feature engineering itself, only how to extract features. People do a whole 5 years of PhD work on this feature engineering process or feature extraction process. It is so important. It is so important. So now that we have these features, we can create a model for our data. Now, this is just a prediction model, this classification, regression, or clustering, what kind of task that we have. Based on that task, we are going to have our own model. Once we have the model, we can do interesting prediction. We can understand the data better. We can see what is the underlying structure of the data. And this will lead us to knowledge. And this is what our objective of data science is. That starting from a raw data, which is put in an Excel file, we are coming to something called knowledge. Okay. Now, knowledge means we not only see what is inside our Excel file or what is inside our database, we also see what is not there. We also see what is behind. Like, it is like just like for watching behind the scenes for a particular movie. We have seen the Avengers movie. The person is jumping from a 30-story high building, or just flying through the air. But when we go to this behind the scenes, we can see that it is only a computer trick, and they are actually performing all the stuff in a studio with a room covered in green canvas and so. So this is behind the scene. So the Excel sheet is the film that we are seeing right now. But if we know data science, we will know that how that film is made. Okay, how that film is made, how the data is something like that we are seeing. And if we can know this, that is the most beautiful thing that we can have about it. Because then based on that, whatever new data comes in our life from the similar domain, we can predict something, that do this, do that. Now, why the whole world was so troubled for COVID is the basic reason is that in our Excel sheet of epidemics, we didn't have something like this. In fact, for a long time, we didn't have something like this. The last one was from 100 years back. But right now, we have seen that, well, this is unseen. This is totally unseen. This spread of pandemic, this disease getting infecting a lot of people. People are getting sick. So what we have here, we don't know. We haven't seen this at all. So how we will deal with it? So all the countries that suffered from the COVID at the beginning were actually shattered by this movement because we didn't have enough data to handle this. But days gone by, people have worked like hell to defend others from this pandemic. Now we have data, some data at least, and we know that how this virus is working, how this is spreading, what we need to do about it, and within 6 to 8 months, we have a potential vaccine candidates, not just one, more than one. So how it was possible? It's not only a biological research anymore. If you read the medical sciences blog nowadays, you will see that the medical science is not only about doing some chemical or biological experiments in a lab. It is also about collecting the data and to process the data in an intelligent way to infer something from it. So in this COVID vaccine creation process, we sincerely hope that we are soon going to have one. Uh, Definitely chemistry and biology and medicine science have helped, but data science also helped a lot. I will say a lot because if you read those things, within these 8 to 9 months, maybe thousands of papers have been published on COVID-19 from the computer science background, that how the epidemic is spreading, how the virus is behaving. So these data also helped the vaccine scientists, the vaccine developers to understand what we should do. So that is the knowledge, that is the data science can do. So let's talk about now the outcome, that what is going to happen. So last 10 years job posting in data science and machine learning, you can see that with something so significant in this scale, what is happening here is a spike. And I told you that in 2020, In spite of the epidemic, in spite of the so green job market, people got recruited. I have seen a lot of my friends have been appointed as data scientists. I myself was appointed as data scientist, and in the most tough time. So you can, um, I will say, you can use this as a benchmark of yourself. That if someone can get a job in this tough situation, then in a good situation, when this pandemic will be over, new companies will merge in, we will also get jobs. Okay, and I am sure that you will get job if you want to pursue this data science course. If you want to go somewhere else, that's fine. But if you want to pursue this data science course, definitely a good career is awaiting you if you follow some rules. I will tell you that later. So nowadays, what is happening also, why data science is gaining even more popularity, because you see, data science is an expensive branch uh, because of this fact. Okay, I hope you can see this figure. It's not very classical to show salary in a academic institution in their introduction, but this is one of your objectives, right? To get a salary that is very decent and that looks very lucrative. We are all aiming for that. So this is the Indian scenario in data science. Okay, so uh, this is the average salary you can get depending on your experience. It can be more, it can be less. So more is here, less is here. The less doesn't look very bad. Okay, uh, if we look at this pan India picture, the less doesn't look very bad, the more looks very good. So uh, if you entitle this session as a motivational talk, then this right hand column and the rightmost values in this right hand column are very motivational, I guess. Okay, so pay little attention that we can reach this mark. I am not saying that this is the goal of the life. I'm not saying this. Okay, but yes, if you are serious about your ambition, your financial ambition, then data science is also a very fruitful line there. Uh, so what I was saying is that data science is also very expensive, because the person who is doing data science uh, has the average base package is much higher for a data scientist. So one company, not every company can afford a team of data scientists. Okay, not every company can afford, but every company needs data science. So how this problem will be solved? The answer is here that companies like me, uh, I'm working in Tatra's Data. Uh, Tatra's Data does these data science solutions and also provide a new thing called data science as service. Maybe you have heard of these terms like infrastructure as a service, database as a service, um, something like that. Software as a service, SaaS. So these are very popular. This was very popular term nowadays. But nowadays another term is coming, that is data science as a service. So what is happening there? So we have a framework. People can use that framework to infer, to do data science processing with their own data without appointing data scientists or appointing less number of data scientists. So everyone, Google, Amazon, Microsoft, they have their cloud computation platforms available online. You know that Azure is a very popular Microsoft cloud platform. Google has GCP, Google Cloud Platform, and Amazon have their celebrated EC2 computation engine, and Amazon SageMaker is there. So these uh, these are not any jargons, right? These are actually very useful, scalable uh, frameworks that you can use for your data science solutions. So your company does not the company that does not have the intention to buy a very high-end computing device for data scientists, doesn't have that much resource to recruit a team of 15 data scientists, but they need the solution. They can use these scalable structures from Amazon, from Google, from this Microsoft, and from many other companies. Not these are giants, but there are lots of other companies who provide the same. So these are the most important things. So data science as a service, this is a new emerging thing. And definitely this is increasing the potential of getting a job as a data scientist in Indian market. So this is a very good news for all of us that if we choose to work in data science, then we are having a whole new framework getting dedicated for us. We are not working in simple outsourced projects, in simple discrete platforms. A whole new framework is right at our disposal. So I think I have discussed enough that why data science is very important, because you can see for the time being is that do only one thing, that the data science not just mm, help us to predict, it also help us to organize our objective, that what we are going to do. Okay, so you see that is a very there is a very important data science use case called tendrils, a work on power management. So the electrical supply lines in every home, and they have the people uses the power. Now the power usage in different regions increases or decreases at different time. Say, let's talk about India. Say in India, the power usage in Diwali or in festivals increases more. Now, Durga Puja is a very famous festival in Kolkata, in West Bengal, but it is not that famous outside it. So the power consumption in West Bengal is different than the rest of the states in India in the month of October. Now, what if we can plan accordingly? What if we use the data science techniques to identify that what is going to be the power consumption of this particular state or this particular region for the next month or the upcoming 2 months, and we can plan accordingly. So you know that this power, so this electricity development corporations or the generators, they buy coal or other fuels to run their factory to produce electricity. But if, what if the we don't need that much power at one particular time? Now, say in this winter, we don't need, we need less power because we are not turning on our fan, we are not turning on our ACs like this. So we need less amount of power. So if a company, the electricity company, he buys more coal, more fossil fuel to burn, but the power is not consumed, then it's lost. Not just the power is lost, a huge amount of expensive fossil fuel is lost. So what they want is that they want to predict. They want to predict. Now, see, in winter, uh, the prediction can be, you cannot be a general prediction about the winter. Then the question is, when is winter? Is it from when I will plan accordingly, from November to February or what? So even we can put more dynamic decisions using data science. Okay, so by looking at the weather, the temperature, the precipitation, and all the other stuff, is there any festival? So these are the features related to this data. So we collect all these features and we try to predict what is going to be the power consumption for this particular region, the region of interest in the next 2 months, and then we will plan accordingly. So that is why you can see that it will not only be very cost effective, but it will be very optimized and it will save a lot of natural resources. So data science is not just about business also, it is also saving the consumption of fossil fuels if in a very optimized way. So you consume fossil fuel, but do not consume it when it is not needed. So it's a very good thing. I can give hundreds of examples of Google how they are using this data science to improve the ecology and natural resources. But I am seriously running out of time here. So I will say that data science is an independent branch now. It is not an applied field of statistics anymore. It is not an applied mathematics anymore. It is not a library of fancy programming techniques anymore. Data science, by its own virtue, is an independent stream now, which is showing tremendous potential in the development of stable, optimized, cost effective business solutions and natural systems. So that is why it is gaining so much popularity. And I sincerely hope that in coming days also, this will people will use more and more data science strategies, data science technologies in future to improve our life in everyday thing. You already start getting these smart devices at your home. Okay, now the smart device does not only mean that you say, hello Alexa, or Alexa, play a song for me. This is not just smart. Smartness is also in saving power. That to understand that, okay, nobody in the room, turn off the lights. The smartness is inside understanding that we are consuming more fuel. So stop the engine of the car because we are not moving. So smartness is not just some fancy human computer interaction, right? With the audio or with the gesture or even with the look of the eye. So when I'm looking at my computer screen, the computer screen is turning on. When I'm moving my eyes away, it is turning off. This can be a very interesting feature. But also the purpose of this is to save power, which is good for our ecology, good for our ecosystem, good for making this world green. So a smart device, which is coming from data science, machine learning kind of domain, is not about only the fancy devices, not about this creative things about these big companies like Apple or Samsung or Microsoft, but they mean a lot more than this. You must look into this bigger picture also. Now, the final thing in my session is that how you want to become a data scientist. Okay, so if the gibberish that I have said so far uh, have somehow interested you, mm, then you may think that, sir, then what will be the process to become a data scientist? If I pass my BTech or MTech, can I straightforward become a data scientist? The answer is yes, definitely you can become a data scientist. But I have jotted down something that you need to know as well. So out of these different technologies that we have, you see the SQL is a very important technology that you learn. You need to learn that that will help the data scientist. So SQL is again what I said at the very beginning of the topic, that we are not discarding PBMS. No, not at all. Even now it is more important, but from a different perspective. So in your course of in this coming course, maybe you have already covered this SQL thing. Maybe you have already covered. Maybe you are going to cover. It is not in your syllabus yet. You will going to cover in this beautiful course that you are pursuing. SQL, you have to be very good with SQL. Not, I will say simple things. I will say simple things in SQL, but you have to be very confident about it. Okay. SQL is one important thing. You have to be very efficient in Python programming also. You can be very efficient in C. That will also do. But most of the machine learning and data science library are now written in Python. Mostly written in Python. So at one point of your time in your career, you have to learn Python. So I will strongly recommend that if you want to learn one programming language right now, after C or Java, you should go for Python. Okay, it will help you in a lot of other researches also, not only data science. Okay, so these two are our takeaway from this. We don't need to know much. Yes, R is one very specific package for data scientists, but for general engineering students, I will recommend that you go for SQL and Python as much as you can. Uh, Now, this is this is a funny thing. You see, I just got this from LinkedIn. The person, maybe a leader, he's asking those people that who wants to learn Python. All of saying yes, we want to learn Python because Python is so trendy nowadays. Uh, every company is asking, do you know Python? You have to say yes, otherwise they will not ask you anything else. Python is so important nowadays. Then that person is asking, who wants to learn math? And you can see the faces. I can see green faces here. People are not happy at all with this question. And then again, this lady is asking, who wants to become a data scientist? And see, the all hands are up again. So this is not good, I will say. You see, this is actually funny because if you want to become a data scientist, you need to learn math also. Don't if you don't like math, I'll say that no, don't be disheartened. This is math is not that serious here. um, what you need to learn, so this is my recipe, okay, that these are the ingredients you need to cook your data science career. So these ingredients are, first of all, if you want to be a data scientist, then you need to learn these two things from probability theory. These are the for the starters. So these two things, you have to understand these two things. These are very interesting, very nice things. Lots of internet resources are there. I'm sure that in your course, you have excellent faculty members here who will teach you these things. So this probability theory, basic probability theory, basic statistics. I have particularly specified what do I mean by basic statistics. So these two chapters should be covered. Central tendency, mean, median, mode, statistical distributions. These things should be covered. Matrix operations, very important. Hmm? You need to learn this matrix operations and what are the different operations in matrix, and you have to go for it. Of course, RDBMS and SQL, they come under one bracket because in your course, I think DBMS and SQL are one integrated subject that you are going to have in one of the semester. Do not miss a class there. Okay, my recommendation is that never miss a class there. Not just for data scientists. You cannot go far away from SQL and DBMS in any of the software industry region. So 4 and 5 are extremely important. And as I've said, that 6, that Python, the most data science algorithms are written in Python. So if you want to use them, you need to understand Python in a very um, deep way. You have to think about Python if you want to really become a scientist. It's so important nowadays. The final thing, this should not come in this list, but there is no other way to put it but in this way, which is the algorithm that you have to learn. If you have a solution in your mind, a problem is given to you, and someone is asking for a solution, you have to write a program for it. So you must understand that how, if I have a solution in my mind, how I can type the solution in a program. Not just any program, we have to write very efficient program. Because in data science, we deal with billions of data. Okay, so the volume of the data is so large that if you don't say the sorting algorithms. So we have many sorting algorithms available. Some of them are more efficient than the others. But if we test them with only 10 or 100 values, the difference will not be clear. But trust me, if we test them with 1 billion data, then the difference will be pretty clear. That what is the reason to find an effective solution, not just a correct solution. So you need to understand, you need to learn how to write efficient program and how to write also a correct program. Okay, these two things, I'm afraid that is not possible to learn from a lecture. This is kind of art. You have to learn that from your mind. So you have to realize the solution. You have to digest the solution in your mind and provide a program as an output. So this is a practice. I cannot give you a quick fix for it, but practice, practice, and practice. Writing programs, writing different logics, thinking in a programmer's way is the only thing that you need to do. And the last thing that I would say is that the one primary thing that you need uh, to become a good data scientist, that you must love all these 7 things. If you don't love, if you don't have any passion for these 7 things, if you cannot see all of them as a in a collective way, then if you don't love that thing, then it will be very difficult for you to deal with it. Okay, so this is my recipe, and I have finished. So that is one quote that I found recently. So what is going to happen next? So they are saying that in Information is the oil of the 21st century. So there are lots of information out there. Okay. But in order to consume that, we need analytics. So analytics is the combustion engine that is used in the cars or something. So we have information, but in order to process that information, we need analytics, because then information will be there, the solution will be there, but if we don't have that analytic skill, we have to stop there, we have to pause there, we won't be able to do anything, even if the solution in front of us, which I'm sure that if uh, you come forward, you young students, you come forward and you take these responsibilities of uh, choosing a career of data analytics, not for your own good, but for the good of the society, uh, it will be very useful for us, because last 5 years industry is so much suffering for the lack of data scientists. So I was discussing with Joybruto last night that what I was thinking is that students are saying, "Sir, we are not getting jobs." Some students are saying that, "Sir, we are not getting jobs." And I am working in an industry, and the recruiting agency, the recruiting team is saying, "Sir, we are not getting good employees." So I was thinking that what is happening? What is happening actually? So what is the gap? Where is the gap? I cannot see that why this student who needs a job is not getting recruited by this recruiter. So the reason why what we came into conclusion, maybe this is the reason that what we lack here is that proper communication in the proper field. So you need to learn the proper skill. It not just goes for data science, for every other software industry field that you can have. You need to learn the proper skills. So very precisely, you have to learn few technologies, then you can approach for it. The second thing, then you need to understand, you have to find the right sector to apply. Okay, so software industry, IT industry is a big thing. So if you have a particular skill, you need to look for that particular organizations who is working in the same. And the third thing, you need to find the right person to guide you, which is not in your hand, unfortunately. You That's luck. Okay, but remember, um, luck comes to the brave people. If you want to be lucky, you need to be brave. So you have a brave new world in front of you. The epidemic is hopefully diminishing. And once that is over, plenty and thousands of jobs will be there. But what industry will lack is skilled professional, skilled professional who can put them into a desk, solve an unseen problem in a logical and optimized way. I'm sure that the course that you are going to follow in coming years will direct you in this, will guide you in this direction. And I'm sure you will be benefited a lot from all this. So I stop here. I have taken enough of your good weekend morning. So I will stop here. If you have any question, you can ask me now. You can ask me anytime. Here is my email ID. Best of luck.
Thank you, Mr. Parthasarathi Mukherjee. Now, I would like to ask to our students to put their question in the QA section, or they may raise their hands. So there is some question in the QA section. One has said that do we need a good knowledge in codings and mathematics in data science?
Yes, I was expecting this question. See, mm, my answer is that you have to be very efficient programmer. Okay, you have to be very efficient programmer. So and what is a very good programmer? Okay, the answer is that your teacher will tell you that this is the data, this is the data that I am giving you, this should be the output from the data. So you are given a black box, you have to figure out what you need to write inside. So efficient programmer can do this thing, that I will just tell that, okay, I need this. Okay, I need this kind of output, and you are given this kind of data. You tell me what you will write inside and do it for me. So this is efficient programming. And about math, yes, of course, we need to learn some math. I'm not saying that you need to be a great mathematician, but you need to learn basic things that I have shown in this thing. Probability theory, basic statistics, basic linear algebra. For data science, you need these things. Okay. For other streams, definitely there are some associated branch in mathematics, because you see, ultimately, computer science itself is a applied mathematics field. Okay, so you cannot keep mathematics away for long. If you are afraid of solving problems in mathematics, I would say that be very precise. You will see that if you mechanically even understand something, then it will work. So it is not very difficult. It is not a rocket science. You will get into it.
Okay, another question from Obhijit Jana. He has asked that how many problems faced when we becomes a data scientist and solution for all problems.
Abhijit, please clarify a little more about what kind of problems you mean. If, if you are talking about problems in increment, then I will say that I haven't faced any problems in increment. But are you talking about management related problems or engineering problems? Be a little more specific. This is a very good question. Everybody listen to this.
Next question from Rahul Datta. Can BCA student build their career in data science and how?
Of course, you can create your career. But again, I'm telling a story for all of you that when we were young in our college days, then what we saw that TCS, Wipro, Infosys, these companies used to come and recruit hundreds of employees from one single college. Okay, the concept of bulk recruitment came from there. That when a giant of such magnitude coming, every student is expecting that they will consume 200 students. Now, this situation is not there anymore. If you ask your friends in different institutes, you will see, read the employment blogs, you will see that this is not the situation anymore. So industry is looking for skilled professional, right? Now, you cannot be a professional when you are in college, but you can be skilled, right? So if you have a, first of all, you have to fix a name that, yes, I want to become a data scientist. Then you need to practice the related or and the relevant technologies or subjects that you need to learn for data scientists. Once you have the skill, no one will ask you, where are you from? Are you from BCA, or are you from history background, or where are you? They just need to see, industry doesn't care about where from you are. They only care about, if I give you a problem, have you do you have the ability to solve it? So once you can assure them, yes, we can, yes, I can, then there is no reason that they will not take you. Okay, if you are from BC and you are saying that you want to be a data scientist, if you follow these directions that I gave you, and if you can really build up your skill, then I will think about, I will forward your resume to the relevant authorities. But you have to show your skill there. Okay, so it doesn't matter that whether you are from BC or what. It not, doesn't matter at all. It goes for any other streams also.
So there was a question related to this that, sir, right now I am pursuing BSc data science and I want to be a data scientist. So sir, my question is, what should I do next, which will be better for my career?
Write programs. Write programs, complete projects. You the most of the algorithms and data science things that we use are very basic. Not very fancy high-end things are used, okay, for production in industry. So you have to write thousands of programs and you have to finish projects. So say you try to build a data science project. I'm sure that you will have some project in your course or somewhere. So you have to finish projects. You have to do something productive, not theoretical solution in pen and paper. You have to write your program. You have to be, again, I'm saying to all of you that you have to be excellent programmers. And that is not a difficult task. You see, there are two kinds of people. One who are genius, who have talents, and they can do anything. Say, a kid, um, a kid who is building an app and getting sold at the age of 7. We are seeing these commercials, right? So he's genius, I think. We don't need to be genius. Okay, we don't need to be genius. Industry doesn't work with genius. Maybe there are genius people there, but industry looks for hard working people. I just want you to do hard work, and the second, you must have love and passion for the thing you are doing. Do programs, write programs, and learn why you are writing that. That's it.
One of the students has asked to explain feature to prediction.
Okay, feature to prediction. So yes, so, what I was showing in that slide was the fact that feature to prediction means that once we want to predict, we see some values and feed those values in a model to predict something, right? But these values may not be sufficient for prediction, right? That one, the example I have shown was a good example for it. So maybe you need to add more parameters or values in your data, or you may need to discard some of the values that are already in your data. So you need a clean and optimal set of values for your data in order to make prediction, right? So say that example. Let's take another example that I want to predict that say at after 12 overs, say Rohit Sharma have scored 56. Okay, so I am trying to predict whether Rohit Sharma will be scoring 100 or not. So maybe I need to also consider the fact that whether Rohit Sharma has a hamstring injury or not. So this is like putting a new value in your data, and then you can do some prediction. So it's all about finding the right set of data for you for prediction, which is significant for data science. And I told you that this feature engineering is itself a field of research. People can do 5 years of research on it and get a PhD.
Okay, so one participant, Lakshman Kumar Shah, has raised his hand. So I request Mr. Prem to give him access. Lakshman, you can unmute yourself and ask your question.
Lakshman Kumar Saha, unmute your mic and please ask your question. Lakshman Kumar Saha. Lakshman, are you there? You can ask your
Okay,
question by
we will.
unmuting. Yes.
Yeah.
Yes, Lakshman. Lakshman Saha. You have unmuted your mic. Now ask your question.
I think there is some problem with Lakshman's mic, so we can move to the next question.
Yeah, we are moving to our next question. That how do we relate software engineering with data science?
Uh, that's a very good question, in fact. So, see, what do we mean by software engineering? Uh, what we read in our books is that software engineering is basically we study about production, right? So, starting from a requirement and mm, finishing the whole product and testing it and delivering it to the client, the hiccups and the factors that we need to consider in it is software engineering, right? So data science is actually one module in our software engineering, software development lifecycle, SDLC. Okay. So what we do here is that right, this is a new module. This is a new module nowadays. This was not before. So it may happen that in regular softwares where no predictive analysis is needed, then they don't need a data science at all. But in in this analytical predictive systems that I was giving examples of, their software is actually a lot different. This SDLC is a lot different. I think, you see, after 5 or 6 years, these parts will be included in the software development lifecycle itself, where uh, we will get some new loops, like infer something from uh, mm, data science models and validate the model using manual feedback system, then it improves the model again. So like a loop. So the model is predicting something about the product or some part of the product. Then someone is validating it or testing whether that prediction is good or not. Then again, it is feeding that into the model, and model is refining itself. So most of the data science mm, modules that are inside a software is basically lifetime. They keep on taking the data and refining it itself. So after slowly, so I'm giving an example here. So see, nowadays the Google gives us very good translations, right? When we type something in Bengali or English, it translates to some other languages. So yes, still we have some imperfection in our translations, but this translation is improving. So if that system of Google is a software which is engineered, then that system also have a module of data sciences prediction system inside it, and which is getting updated every now and then, taking input from us by validation. Maybe after 10 years or so, we will see that, or maybe even faster than that, we will see that this system is sufficient. It does not need any refinement. It is a gold system. It can translate anything. So data science modules in a software engineering domain is continuously evolving and adjusting to new challenges. Okay, which this part will be more popular in coming days.
Okay, so related to that, there was a question that as a data scientist, what do you hold to your stakeholders in terms of product and application or a presentation?
Well, right now the projects, most of the projects, what we are dealing with, in fact, every data science company is dealing with those projects. So these projects are so far handled by manual systems. Okay, but now these companies want to incorporate AI-based assistant to these systems, right? So I'm giving an example. So say there is a software which is identifying a potential buyer for a particular product. Okay, say that particular company is building some electrical cables. So this company is interested about finding out who are the potential buyers of the particular product, that electrical cable. So what used to happen is that they used to recruit 2 or 3 persons who will browse internet and find out what companies used to work in this domain who have requirement in electrical cables. So now these company want that yes, these 2 persons are working in their own, but they want us to develop a software which will automatically crawl through web pages and gather information from them, and then try to find from the information using natural language processing that whether that company is interested in electrical cables or not. So now two modules are working parallel. One module where the manual validation or manual exploration is working on in a traditional way, and in parallel approach, an AI-based assistance is helping those manual validators or explorers to give some pre-processed data. But I'm very sorry to say that the way this is working, it will affect jobs. I'm sorry to say that those manual explorations are getting less day by day. This is what I am seeing. This is a fact. We need to accept this fact, but that is happening.
Okay, so next question is, sir, is C not enough to become a data scientist? I mean,
Not
C language.
not
Yeah.
directly, not directly. But if you want to understand Python, you need to learn C. C is, you see, C is only important in production if some people are working in the embedding systems. So if you are working in a machine learning domain with embedding system, that some people are building chips where or integrated circuits where some smart integrated circuits, then you need this understanding of data science and C as well. But in most of the companies, the libraries that they use are based on Python. So it's a good time to migrate from C to Python. But do not forget, I'm not saying that you will forget C. No, I'm not saying that. I'm simply saying that C is the new, C is the foundation for you. Will work as a foundation for you to understand algorithm, to implement algorithm, and to shift to Python as well.
Okay. Is data science used in election purpose?
Uh, you know the answer is yes, right? You definitely know the answer is yes. Yes, but what I think you are asking mm, is it used in a good way?
Yes.
Uh, I think I am too inexperienced to answer that, but I doubt it is. I don't think it is getting used in a good way. It is not, at least in our country. Not, I think, in any one countries, because the persons who are using data science in election is not thinking straight. I must say that. We can have separate talk on this later, I guess. Maybe
Yes.
not in an official channel.
So next question is, can we link cybersecurity with data science?
The answer is that how you want to link that. Definitely, well, you see, the intelligent systems can track your personal choices, your personal preferences by looking at your social media feeds, your activities over the internet, and what they can do with that is that they can use your data to sell to suppose you watch a particular product. Suppose you want to buy something, like you are interested in a gaming console like PlayStation or something. So you sometimes explore in Google, or sometimes you see that in Facebook someone has bought it. You are giving a like that yes, he has bought something nice, and the analytics engine is looking at that, and you will see that you are getting relevant ads, right? You already see that the ad that pop up in your browsing are relevant to your search. So, if you think that is a breach to your personal space, then of course they are using analytics to as a infiltration in security. But most of the people want it, na? Uh, they like to see ads that they are interested in. That's why they click there. So I think it's a condition where few people like this thing and some people does not like this thing. But my feeling is that when I am, see, my point is that when I open Amazon or something, I want to see the product of my preference comes at top. This is not possible without allowing the analytics engine to intervene my search history. So I'm kind of allowing the breach in security so that I get some facilities, which I don't know what will happen after 10 years. But right now it is the case. We are driven by consumerism.
So is there any certification needed to field of data science to get job in MNC company?
The MNC companies want to see that you have done something in data science, but a project in data science will do from a institute like yours. So if you say that I have these skills in your CV, and well, one interesting thing that the companies use data science to filter CVs. The MNCs use data science to filter CVs. The days are gone when one person used to open the CV and see whether this candidate is eligible for us or not. They use data science to process the CVs. So, uh, what will happen is that if you have the skill set in specified in your CV from any source, it can be, it will be you will automatically be selected for the next round. And once you are in the interview round, it is up to you how you can impress them. So yes, a certificate can always do something good, but if you have the skills from any other sources, that will do. I don't have any certificates.
Sir, I am a student of BSc Data Science. So my question is that to become a data scientist, is it mandatory to do the master degree?
Right now, not, but eventually it will be. Because what will happen is that right now, without a master degree, we'll get a job in data scientist. They will not look for it. But after a few years, you will say that I want some increments. I want to move on. So say I'm working right now as a junior data scientist. I want to move to data scientist, and then I want to move to chief data scientist and something. Then uh, a master degree will help, surely. So it's better to have a master degree. It's not eligibility right now to have a master degree, but yes, some startups are also looking for master degree as minimum right now. So I'd say that if you have resources like time and money to complete your master degree, then I will say that do it, and then you apply. If you don't do that, then go to your job, try to do the master degree while doing your job using some online courses or something like that. But at one point of your career, you have to finish your master degree.
Okay, one question from Shomik. Why should anyone study BSc in data science when he or she can build career in it studying otherwise courses like BCA or computer science?
Without hurting the students of BSc data science, I want to say that uh, ultimately you need to put the skills in your CV. You need to show in your CV that I know probability and statistics, I have worked in Python, I know SQL, I have completed data science projects. That's all. We, if you have something specific BSc in data science, yes, it's okay. Definitely, it will be appreciated, but you will not get rejected if you don't have that degree. So the ultimate thing that you need is the skills. Again, I'm saying in your CV, you must have these points that I know these data science skills. I'm good with logistic regression. I have done something with CNN, something like that. That will work. That will work.
Okay. So respected sir, according to you, which is more important in terms of importance, data scientists or cybersecurity experts?
These are different non-overlapping fields, so yes, cybersecurity experts are of course very important. It's an important designation, but if you look at the if you search the number of jobs getting posted, then you will see that the data science job posting is higher. uh, but that doesn't mean that the cybersecurity jobs are not there. But I think compared see, if you are inclined to inclined to this field, cybersecurity, if you like cybersecurity field, then I will say that you go for it. You will get a job there. There is these jobs, but um, if you are unsure that whether data science and cybersecurity, and you have same preference for both of them, then I will say that the opportunity is a little higher in data science. So I think the probability of getting an interview call in data science is a little higher than probability of getting a interview call in cybersecurity. This is a very naive answer from me, but um, I think it is. It is unfortunately or fortunately the case.
So Avantika has asked, can you please let us know about what kind of jobs are offered through the data science stream? So I
The first designation that you can expect is data analytic uh, or data analytics engineer. Okay, this is a very basic job in data science where people will expect you to collect data, gather some feature from it, do some exploratory analysis. So it will be concentrated on the more data acquisition part rather than this analysis part. Uh, then you from this junior data scientist, data engineers, you can move to data science like a junior data scientist, or if you have that kind of skill, then you can straightforward move to data scientist itself, which is a very nice designation. A data scientist in some company is a nice designation because this is very well defined. So, data engineer is one designation. Junior data scientist or trainee data scientist or something like that is one designation. This is level one of data science. Level two of data science is data scientist, which is quite a good one. So if you reach data scientist, then it's okay. You have achieved a milestone in your career. You can stay there longer. It's a good designation, and eventually, once you are in data scientist, then you can automatically move to chief data scientists or principal data scientist in due course of time without any extra degree or something. So only the experience as a data scientist is enough to give you an increment or an upliftment to the post of um, data science team lead or data science chief data scientist. Okay, and the perks are high.
so one has asked that, sir, as you work in company, is it possible to complete my study during working in company?
It depends on the company itself. In my company, yes, I am blessed with a great mentor, Dr. Sarabjot Singh Anand from Tatras Data. He's the great mentor. I am learning so much from him that I cannot explain in words. Um, uh, he's just such a wonderful person that he runs his own training institute parallelly, and he always encourages his data scientists to learn from other sources. So if a data scientist is doing um, a study, he also allows him to go to college and do the study for his own improvement. But I'm not sure how many company allows that. Um, I'm sure that it will be a little difficult that you work in a company and at the same time you do a full-time course. Um, I think it will depend on the company management itself. But for my company, they allow it with admiration, which is the most beautiful thing.
Okay, so one has asked, are there government jobs as data scientist?
I'm not sure. I'm sure there are data analytics job, but uh, I think if even if they have jobs, that's not too much. And I'm not very sure that whether they directly recruit a data scientist, a fresher as a data scientist there. Uh, I'm sorry, I'm leaving this question. I have not very, mm, I don't have any clear idea because I haven't searched the government sector at all when I was looking for data scientist jobs. Maybe because government is dealing with lots of data, they should have a data science post. But right now, I don't think um, there are too many data science posts. I'm not very sure.
So there is an incomplete question that there are any link in AI and data science, but which type of link he has asked for?
Yes, this is a good question. This is a good question. I'm sorry, I should have covered this in my presentation, but for by thinking about the brevity, I removed this part. Uh, of course, it is linked. Of course, it is linked. AI is a general study of how we can do some intelligent decisions based on a scenario, a computer aided um, mm, solution, how we can provide a computer aided solution for a particular type of problem. Definitely data science is a part of it. So AI is the larger picture, and data science is a part of it. So it's a subset of that. It's a very specific. Data science is very specific in terms of the application, and of course, it is quite well linked with AI. Very well linked with AI. I could have given another example, but yes. Sometimes we get a designation like data scientist, principal data scientist, or principal AI architect also in the same course of study. You can expect this designation also, principal AI architect or AI architect or AI engineer, something. Some company name it like this also, but the role is quite similar to data science. Does it answer your question?
So Naim Badshah has so many questions, so
I'm happy to take. I have no problem. If you have no problem, I have no problem. I'm
okay, so
very
I'm
happy that people are
requesting.
asking questions.
Okay, I'm requesting Mr. Prem to give him a chance to unmute himself so that he can ask the.
Okay, hello sir.
Yes.
Uh, so my first question is, Agile is nowadays acquiring data science. So
Yes.
what's your take on this? I mean, do you say? I mean, please say something about this.
What is? I want to like what you think about this. You think it is in a good way or bad way?
Of course, it is a good way because so many companies are acquiring. I mean, works on agile methodology. So it is a good way, I think.
Definitely, it's a good way because you see that I was saying this in my slide also that so many companies have understood that data science can save a lot of cost and time, a lot of
Mm-hmm.
expenditure and time. So that is why they are investing in it. And as they are investing in these new technologies and these existing cream technologies along with data science, the data scientists are overjoyed that yes, my stream is live even more. So I can expect now this integration means we are having new opportunities to study, we are
Yes, sir.
having new scopes of study, so new job opportunities. And
Mm-hmm.
definitely if I am specialist in this, I will expect a little hike in that thing for what we are working. So definitely this is a very good thing. And actually not just this technology, you will see that thousands of other technologies where we didn't have expected data science to be there will be adopting data science very soon. One of them is going to be medicine sciences and medicine development frameworks. They have already incorporated data science in their unit. Uh, there will be even more. You will see that very soon we will have specific requirements for people who are working in data science in medical fields. It is coming. It is coming within 5 6 years. You will see that hospitals are using data science people. These
Yeah.
big houses are using data science people. Already they're using. Already they're using. They don't say it openly, but they're using.
Yes. And my next question is, what might be the reasons when a data science project failed?
Project fails.
Failed. I mean,
Oh,
what
yes,
might be
yes.
the reason? Yeah.
Oh, yes. The it is a very common situation, I will tell you. But the reasons can be this: that first of all, the scarcity of data can be a reason. That what I want to achieve, for that we don't have sufficient data right now. So right
Okay.
now, the data science project is not giving good output. Fail is a very difficult word for data science because I have said that
Okay.
data science is a continuous process. So right now
Okay.
the data science is giving not a good output, in fact bad output.
Okay.
Doesn't mean that the algorithm has failed, because the
Mm-hmm.
success of a data science project depends on the availability of the data, and of course what kind of computation resource and algorithms we are using for that. So maybe
Mm-hmm.
we have sufficient amount of data, but we are not able to afford computation resources, enough computation resources. I think Mr. Joybrata Chakraborty can illustrate this in a very nice way. He is the sufferer of this. That we have that a lot of data is there, but for the lack of computation resources and this GPU computation and other stuff, we are not able to run our algorithms. So that is why we are not getting good results. So that's why the project is failing. But uh, mm, I will say that the data scientist is not responsible for that
Yeah,
always.
sir. Yeah, yeah,
Okay,
yeah. Sir, we are the students of MTech in data science.
very good,
So,
very good.
sir, can you mentor us? I mean, can you be a mentor for us?
Well, I am not that good data scientist, you know. I will like to help, but yes, this
Sir,
should
we are
come from an
nothing,
office.
sir. We are also
No, no, no.
nothing,
This
sir.
is
We
a
need mentoring.
no, no. I'm happy. Be happy to mentoring, but well, let's talk on this later. Okay,
Okay, sir.
I
Okay.
think you should talk to your department about this and Mr. Joy Chakraborty and Bapadev Chakraborty, who are even better data scientists than me. Though they are, thankfully, they're teaching you, but they're teaching in your department, but they are better data scientists than me. Trust me.
Thank you, sir. Thank you so much for answering my questions, sir. Thank you.
No problem. I'm very happy that you asked.
Okay, there is a question that, sir, why the salary in Kolkata lower than other cities, and is it possible to get a job easily abroad?
In Pan India, if you are looking for data science jobs in Pan India, your chance of success is very high. If you're looking for data science jobs in Kolkata, it is scarce because Kolkata is suffering for projects, good expensive projects, because data science projects are little expensive. You can see the package that the main condition is that for data scientists they need very expensive computation resources. One and two, they need they are actually the package is very high for data scientists. So the project must be very expensive also. The very few companies in Kolkata have such expensive projects running here. You know the reasons. I won't like to say. I would like to say anything about it, but yes, the chances of getting a job outside Kolkata is much greater than in Kolkata itself. And I'll say the quality of job also. Okay, it may happen that you are working in a company as a data scientist, but you are only applying filters on Excel sheet. That can also happen. Um, I'm not saying that is not data science, but you will not be happy after you complete your MTech in data science or BTech in data science and then do work on Excels only. You will feel tired. So the quality of the job also matters. So um, South India is one very prospective regions of data scientists. But once I got in this company, my company is in Delhi. So I saw that the Delhi NCR is also have some very nice companies in data science and analytics. I didn't know that before. I was thinking that only the data science companies, most of the data science and machine learning companies are concentrated in South, Bangalore or Chennai. Yes, that is the case, but also the Delhi NCR region is doing very good. They are very nice companies there also. I didn't know that before.
Okay, so one has asked, are there any jobs in ISRO and DRDO as a data
Yes,
scientist?
yes, there are. They are handling lots of data. They are looking for lots of data. So they have, but I'm not sure how they recruit or what eligibility they refer. But one thing I'm saying that if they recruit, then lots of IIT guys will also apply for that post. The competition will be a little higher at that point. So ISRO has one advantage. They do production level work, also research level work. So they have two things: one R&D and one is the production. So that's in that perspective, ISRO is a good a good office to work in and for data science. Maybe they will not designate you as data scientist, maybe something like AI engineer or something, but there is such roles. Maybe not by name, but there are.
So one has asked, what are the things you should have done in our age?
Learn mathematics from Joybroto more. The only thing that I want to redo in the old days is that I would have loved to learn more mathematics. That's all, nothing else. Everything else I did right. Everything else I did right. It's not that I'm proud of it, but what I missed is that I should have done more mathematics at that time. I could be more confident now if I have more strong mathematical foundation like those guys. But I would have done that better.
Sir, how does mathematics helps in machine learning? I mean, in real time.
You will get immense confidence when a new model will come to you. So when you will see so what happens is that first we look at an algorithm or a method or a principle. Then we implement a program according to it to work it with our data. You will feel immense confidence if your mathematical base is strong, because the first principle that comes to you is mathematical. Okay, so I'm giving an example. If it's not too much, if I'm giving an example, suppose you have a list of data sets where you have collected the age of people. Okay, and you have collected it in an Excel sheet. So ages are like say 30, 40, 50, and the next age was 60. But someone have typed incorrectly and typed 600. Okay, so now you have data like 30, 40, 50, and 600. So you have plenty of this. So it is not possible for you to look at every data and check whether it is a typographical error or not. So what data scientists do? What we do is that first we find the average. Okay. So what will be the average if we take these four data, 30, 40, 50, and 600? So the average will be something like something in the range of hundreds, right? Maybe something like 300 or something.
Yes, sir.
So we will keep it in hand. We will try to some. Okay, so from this data, the average is this. But you can see that clearly the average is distorted. The average is not correct. This cannot be the average because there is error in the data. So what you will do is that if you are good in mathematics, you will see that, so if there is possible error in the data, let's find the median.
Yeah.
And if you take the median, you will see that this median is much less than the average. So it will be 50 or 40 or 45. So
There must be some outliers in the data.
yes. So you will instantly find out that there is something wrong with the data.
Yeah.
So who is helping here? Not any program is helping here. Mathematics is helping here, right?
Yeah, yeah.
If you say statistics, then yes, that is helping here. So that is the answer of your question.
Yes, sir. One more question is that in terms of mathematics, there are so many. I mean, are you talking about statistics, linear algebra, calculus? In which area a data scientist, emerging data scientist should practice more?
If he wants to work for R&D sector, then he need to work in much detail in linear algebra. If he is working with neural network models, he should also look for calculus, differential calculus. But if he's working in the production level, then the list that I was given was good.
Okay,
only the elementary ideas, but that should be very sound. The elementary idea doesn't mean that you can only solve some problems with it. No, you should be sound with it. So I said that conditional probability there. You remember? So you must be very clear in your mind what is conditional probability. What is the theoretical foundation of conditional probability? We are not asking for much, but we are asking for a precise and correct understanding. That's all.
Yeah. Thank you.
Okay, so one has asked that I am a MSc data science student. Can I join a company now sitting at home?
Are you applying? Then I see no reason why you cannot, because lots of companies are offering work from home nowadays. I am myself working from in this method, work from home. So there is no reason that you won't get a job. But are you in the final semester? Because the companies are looking for final semester students. So if you are in final semester, you have the necessary skills, you have done some projects. Projects are very important in your CV. Very important. Good, serious projects are very important. So if you have that and you have applied through proper channels, then you should be getting a call.
So Suparno Sarkar has raised his hand. Mr. Prem, please give him a chance. Yeah, Suparno Sarkar, you can now unmute yourself.
Yes, Suparno?
Am I audible?
Yes, you are audible.
Yeah, so my question was that, can you define a pathway, like in which language, after that, which framework or which technology should we learn? Like, I'm a first year BTech student.
For you, a pathway right now will sound very complicated. But right now, I will say that this is a good question. In fact, I think this is a question for a lot of students there who are interested in data science field. I will say that you learn these basic mathematics things, right? This matrix operation. You have to be excellent in matrix operations. Then you learn the fundamentals of probability and the fundamental statistics that I mentioned. And you start writing thousands and thousands lines of code. So again, I'm saying this again and again, that you have to be extremely efficient with coding, extremely efficient, and hard work can reach you there, nothing else. You don't need to be a genius for that. Hard work, extreme hard work. So I, at one point of time in my life, used to work a whole day in an engineering college, delivering lectures, then go to an institute, then come back and go to ISI, and then get back home and open my laptop and start working on the project that ISI was given. Then I was doing my MTech final year, and then I was also doing my MTech project from ISI. So that point, like I was working 16, 17 hours a day, and I was writing programs with very little computation resource in my hand. So I was running my programs in laptop, which was not working. I am sure that your institute have good computation resources where you can run this GPU integrated programs for neural networks, and definitely most of the institutes have these things nowadays. That encourages the student to pursue these courses. So I'm sure that if you follow this, write programs. My only solution to this: write programs. You write every program by yourself. Do not rely on the library functions always. Try to implement from scratch, and that's my pathway. Write programs. The language doesn't matter. You can write programs in C, you can write programs in Java, you can write programs in C++, you can write programs in Python. Doesn't matter. Write your programs. You have to be extremely skilled in programming.
Okay, so one has asked, sir, after studying data science, are there any jobs other than data scientist?
Mm, Of course it is, but again, what I was saying is that the companies are looking for specific professional skills. So when you have you have completed data science, you will not have the skills related to computer architecture, right? So you cannot apply in these companies. Even if you apply, they will see that you don't have done anything with this computer architecture or embedded systems. Then they will not accept you. But I think if you complete data science, then you don't need to think of any other domains at all. The data domains is good enough to accommodate all the data scientists that are coming out right now. Lots of jobs, but not enough skilled professionals. So yes, similar domains can be there, but mm, that's it.
Okay, so students has asked about your, contact information, and they want to contact with you further.
So I had given, okay, I will send this PowerPoint that I was showing, and the last page you will see that my email ID was there. So my email ID is also with some of the faculty members of your institute, Joy Broto Bapadi, to have that. I think Bipasha madam also have that because she sent us a mail. So ma'am, you can share this mail ID with them. They
Yeah,
can
okay. I will
hit me with
definitely
any
share it to
questions.
you, students. Yeah.
I'll be happy to.
So some most of them has asked another session with you actually, and there are some compliments from the student sides. They had written there that this is one of the best webinars of MAKAUT I have ever done. Thank you, sir, for the session.
That's an honor. That's an honor being with you. I'm so happy that you liked this session, and I will be definitely be happy to come again and talk with you something. This time maybe a little more technical things that I know. I always believed in knowledge sharing. So yes, if I get chance, I will definitely come back and discuss these things. I enjoyed this also. Thank you.
So on behalf of our department, I again thanking you to make us privileged through your fantastic knowledge sharing on data science and also the
That's fine.
suggestions and question answer session.
Thank you.
And
Thank
thank
you
you,
so much.
thank you.
Thank you so much. Okay. So can I leave now?
Yes, yes.
Thank you. Thank you, everyone.
So now we have a yoga session with Mr. Devobroto and Ms. Soma. So students are requested to join the session with the experts. So Mr. Devobroto and Ms. Soma, are you there?
Yes, yes, yes.
Yes, yes, yes.
Yes.
Yes, you are visible and audible as well. So you can start the session.
Soma,
At
you can
first,
start
student
the warm-up session.
visible.
Yes, yes. You are visible.
Good afternoon, all of you and students. So I am starting the freehand exercise. So follow this exercise and do this exercise. Okay. At first, your neck, left side and right side bend. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And slowly bend left side and right side. 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, 10. Okay. Then neck up and down, forward and backward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then both hands your up shoulder level. Can you visible? Hello students.
Yes, yes, you are visible.
Yes. Up and down. Palm up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then both hand up and down on the head. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And both hand fold from the knee and shoulder level. Touch your palm shoulder and both hand circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and back. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And both hand wrist rotation. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And back. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then left hand, right side on the knee, keep on the knee. Then right hand forward and stretch your body. Left side, stretch your body and hold. 1, 2, 3, 4, 5. Then opposite, right hand keep on your knee and left hand right side stretch. 1, 2, 3, 4, 5. Then again 1, 2, 3, 4, 5. Then again 1, 2, 3, 4, 5. Then your hip up and down. 1, 2, 3, 4, 5. Head touch on the floor and backside your head and upper body as much as possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then both palm touch left side and look left side. Okay, and stretch and hold. 1, 2, 3, 4, 5. Relax. Then right side. 1, 2, 3, 4, 5. Again left side. 1, 2, 3, 4, 5. Right side. 1, 2, 3, 4, 5. Then both leg stretch forward and close both leg and your legs finger up and down. Means your foot up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And one foot down and one foot up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Both leg fingers round. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And back side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And your upper body down and up. And touch as much as possible, touch your forehead on the knee. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Repeat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is very important because it is your excessive belly fat, abdominal organ is decreased. Then now start the Surya Pranam. Are you visible? Hello, student.
Yes,
Yes.
you are visible. You can continue.
Now start the Surya Pranam. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Relax. So step by step explain. At first, like a pranam. 1 step, then 2. It is called Ardha Chandrasana. Then 3. It is called Padahastasana. 3. Then 4. Then 5. It is called Parvatasana. Then 6. Then 7. It is called Bhujangasana. Then 8. Again Parvatasana. Then 9. Then 10. Then 11. Then relax. Okay. It is practice morning and evening, day by day, 4 times. Your body and your physically, mentally, everything will be good. দাদা তুমি এবার কিছু প্রণাম করাবে নাকি? না আমি আসন দেখাবো। হ্যালো দেবব্রত দা।
Yes, yes.
হ্যালো।
I will start a pranayama. Yes. Hello. Hello, I am audible.
Yes. Please continue.
Good afternoon, all my dear students. Today we have completed the practicing Surya Namaskar and warm-up part. Then we are practicing pranayama, Laghu pranayama. At first we are sitting in Padasana, or as much as possible is Sukhasana. You're just comfortable this position. You can this position that is called Sukhasana, and also both palms should be keep on your knees, and palm should be both palm is the called a Gyana Mudra. And at first you just inhale, slow inhale, and slow exhale, very slow. Now again, slow inhale, 1, 2, 3, 4. Then slow exhale, very slow, 1, 2, 3, 4. And again, slow inhale, slow inhale, slow and slow. And hold your breathing, hold 1, 2, 3, 4. Then slow exhale, very slow. 1, 2, 3, 4. Then again, slow inhale, slow, very slow, very slow, very slow. Hold your breathing, hold your breathing, hold your breathing. Now, just exhale your breathing, exhale, 3, 4, 5, 6. And again, inhale, 1, 2, 3, and 4. Then hold your breathing, 1, 2, 3, 4. Then slow exhale, count 8. 1, 2, 3, 4, 5, 6, 7, 8. And again, slow inhale, 4 count. 1, 2, 3 inhale, 4 inhale. Hold your breathing, hold your breathing. 1, 2, 3, 4. And again exhale, 8 count. 1, 2, 3, 4, 5, 6, 7, 8. And again inhale, 1, 2, 3, 4. And hold the breathing, hold and exhale, 1, 2, 3, 4, 5, 6, 7, and 8. Again, inhale, 1, 2, 3, 4. And hold the breathing, hold the breathing. Now exhale, 1, 2, 3, 4, 5, 6, 7, 8. Now close your eyes. Just concentrate your normal breathing. You just bring a normal breathing process. Start a normal breathing process. Very slow inhale and slow exhale. Very slow inhale and slow exhale. Very slow. Very slow inhale and slow exhale. Very slow. Today's practice in this pranayama name is Laghu pranayama. Your all participants are beginner, so at first you are practicing Laghu pranayama. Okay. Then again, Laghu pranayama's second step. You can start the second pranayama. Deep inhale, deep inhale, deep inhale. 3 count, you just totally complete your inhale process. And holding process is holding your ear in your chest. 6 count. 1, 2, 3, 4, 5, 6. Then you are completely exhale. Total ear exhale your outside your chest. 1, 2, 3, 6, 4, 5, 6, 7, 8. And exhale here also very forcefully. Inhale, 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 completely inhale. And hold, 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 hold the ear, hold the ear. Then completely exhale, very slow and completely exhale. Total ear exhale, total ear exhale. 4, 5, 6, 7, 8. Just total completely exhale in your ear. Then again inhale, deep inhale, deep inhale, deep inhale, deep inhale, and hold the ear, hold the air, hold the air, and completely exhale. Completely exhale. 3, 4, 5, 6, 7, 8, 9, and 10. Then again, deep inhale. Count 3. 1, 2, 3. Now hold your ear. Now hold your ear. Then completely exhale, very slow, very slow. Completely exhale, very slow, very slow, very slow, very slow, very slow, very slow, very slow. But you don't open your eyes. Don't open your eyes. Don't open your eyes. You just concentrate your normal breathing process. You just concentrate on your normal breathing process. Very slow inhale and slow exhale. Now you just feel your breathing process very smoothly. You just feel your breathing process is very smoothly. You just feel. Now both thumb is blocked in your both ears, both palm block in your ears, and another fingers also to cover the eyes. Both fingers are covered the eyes, and eyes also close. Eyes also close, and both mouth is, don't open your mouth, but don't open your mouth, and very slow, and as much as you're possible, Om chanting. Then again inhale and again start the Om chanting. Then again Om chanting. Last one. Very slow, both hands keep on your knees, but don't open your eyes. But don't open your eyes. Both hands keep on your knees, but don't open your eyes. But don't open your eyes. You just concentrate. You just concentrate on your chest. You just feel slowly vibration in the chest muscle. Slowly vibration. You just feel the vibration in your chest muscle. You just feel, and also totally relax your respiratory system as much as you relax your lungs. Very relax your lungs. You just feel to relax your whole body. You just feel to relax your whole body, especially to concentrate of your back muscle. You just feel to relax 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 your back muscle. Now you just feel to relax your hip, thighs, knee, ankle, and also toes. It's just very slow, relaxing process start in your body. So you can just feel to relax, very slow, relax, relax, and relax. Very slow, relax, relax, and relax. Now, both palm is rubbing. Now, rubbing your palm. Now, rubbing your palm, and product technique to both palm touching your total facial muscle. But don't open your eyes. But don't open your eyes. But don't open your eyes. And again, rubbing your palm. But again, rubbing your palm. And then again, both palm touching your facial muscle. And then again third time, and last time you're rubbing your palm. And also touching your facial muscle, and very slow open your eyes. Very slow open your eyes. Very slow open your eyes. And at first you see the left side, and then very slow see the right side. Thank you. Today's our yoga session is complete. So Soma, you can say anything?
No.
Okay. Vipasha ma'am?
Next session.
Okay. Thank you, Mr. Devabroto. Thank you, Ms. Soma.
Yes.
Thank you for today's session. Yeah.
Yes. Have a good day, all my students and all my delegates.
Thank you.
Oh.
So today that was all, and we have a session with Ms. Adjita Senapati from Software Developer CTS Kolkata on 30th November, that is the Monday, and we hope that all the students will take part on that deliberation. And that was today's session, and I thank you all the students and the speaker and the yoga experts. And now I would like to terminate today's session. Thank you all. Have a good day.